Good evening. I am Ethan Freimark, and today I will be presenting my final project covering the known vulnerabilities in Perl. So, to begin, the agenda for this discussion will start with an introduction, and then that will lead into a statistical analysis covering the 109 CVEs that I covered. Then we will move on to an in-depth discussion of 3 individual CVEs, and at the end, a conclusion. So, introduction. Like I said, the project surveys 109 common vulnerabilities and exposures in order to find the trends for the most vulnerable aspect of the Perl programming language. And then I surveyed 3 of what I found to be the most interesting or important CVEs from the analyzed sample. So the statistical analysis, it covered specifically a number of attack vectors that I found to be the most prevalent. That was a subjective choice, so there are definitely more to be found or analyzed. Although I chose specifically module-based attacks, regular expressions included denial of service, file modifications, remote execution, buffer overflows, and Git. So the primary result I found was that the majority, the highest majority of the CVEs resulted in denial of services, and then the second highest was 30% used regular expressions. And here's a histogram for that specifically. You can pause at this point to analyze the statistics. All right, the first common vulnerability and exposure that I covered was based in 2017. It was number 14,867. It covered bash, subshell abuse, and Git. So this was a fairly simple CVE to cover. It wasn't that complex, although why it stood out to me was the fact that it utilized Git. Git is probably one of the most prominently and prevalently used pieces of software in the software development or IT world. Any software development firm, company, business also will most likely be interfacing with sensitive information, be it government contract work, sensitive client information, or just simply software that they don't want to be exposed to the general public. So if an exploit involving Git were to come out, it could essentially expose any of those past topics I just listed, and put many businesses in danger. I know the company that I work for specifically would be very in trouble if they were to be a part of this exploit at the time. So, further covering this exploit, we can see it listed here under cvemiter.org. Specifically says uses unsafe Git before these versions uses unsafe Perl scripts to support subcommands such as CVS server, which allows attackers to execute arbitrary operating system commands via shell meta characters and a module name. So to explain what that is in layman's terms, we'll essentially try to replicate that without using the actual exploit itself. It's a very easy to replicate type of thing. So we can see here I already have cooked up a bit of code to play with. So in this Perl file, we can see and demonstrate this file, or we can imagine that this file right here, the my file variable, would be a variable that the user might have indirect or direct access to modify. And then let's say this is the script being invoked by the Git shell in the CVS server, and that being invoked. So if we run that file, we can interact with bash code, which we can tell right here, this is not Perl, this is bash. Touch command is not present in Perl. So using these backticks right here denotes it's a legacy method of invoking a bash subshell. The file here would be something malicious that the user could attempt to upload or point towards a path, anything that they wanted it to be. So let's run that and see what happens. Fairly self-explanatory, but we'll do it. Then we can see previously this malicious file wasn't here. So running that command, essentially running git shell, invokes bash subscripts that can be modified by the user in some way, shape, or form. And in modifying those bash subscripts, you can cause different or malicious commands to take place. So if you wanted to delete files, reroute files, save files for yourself, or get a reverse shell, that would definitely be doable in this case. Okay, moving on to the second, or no, further. Still some information on this one. So going off of that, just showing how popular Git is in the first place. From 2010, Git utilized, only about over 20,000 repositories utilize Git. Now in 2021, the statistic isn't here, but we're at over 1 million repositories utilizing Git. So it's by far the most popular source code management platform. Many companies would be jeopardized if this exploit were still a thing, although fortunately it's been fixed. So the second common vulnerability and exposure that I covered was 2014-0477. This one covers inefficient regular expressions in a certain Perl module dealing with email addresses. So the thing about this one is in dealing with regular expressions, most programmers will see them and run. Even my boss, my senior engineer at work, runs from regular expressions. They're extremely convoluted, and nobody likes dealing with them, although it's a necessary evil at times. And then further, in this case specifically, we have multiple levels of nested regular expressions, which just makes it incredibly convoluted and hard to understand. So in this case, we can see one of the regular expressions being invoked here. It doesn't look that convoluted right off the bat. You're just searching for a pattern in a quoted string. Though once you look at it, this variable here, CFWS, this variable, QContent, and CFWS again, are further nested regular expressions. The fix for this, or rather, let's hit the problem first. The problem for this, essentially, is covered here. So the parse function in email address module before 1.905 for Perl uses an inefficient regular expression, which allows remote attackers to cause a denial of service for CPU consumption when they quote an empty string on an email address. So, like that picture, that's where I pulled it from, we can see that the fix here is changing the plus conjoin quantifier to a star conjoining quantifier. Right off the bat, we can already ignore almost everything else because this has been documented to be the commit that fixed this CVE. So we know that the only change here is plus to star. So we need to figure out what plus to star exactly does. So right here, listed on modernperlbooks.com, the one or more quantifier, or plus, matches only if there is at least one of the quantified atom. And what the fix was, the 0 or more quantifier matches 0 or more instances of the quantified atom. So the original issue was in that we're trying to find an empty string. And in what we're looking for, there's almost always going to be an empty string. So once we find that initial match, we're just going to continue to keep looking. And that's what causes the denial of service. Our processor gets hung up on continuously looking for more and more and more matches, meaning that we essentially can't use the computer. Not in all times, it won't just be a home use computer. It might be a firewall server, or it might be a SQL server. Dependent on what is hit with this vulnerability, you could see different levels of damage in a business or a home or any network, etc. So, further, the third common vulnerability exposure covered was of this year, 2021, number 29,662. So the versions affected here prior to 0.29. So pulling up the documentation for this, we can see that the data validate IP module through 0.29 for Perl does not properly consider extraneous zero characters at the beginning of an IP address string, which in some situations allows attackers to bypass access control that is based on an IP address. So I've created another example to display here. So we will go to this directory and we'll test this. I believe it was this script. No. Maybe this. No. Where was it? Well, regardless, we can go back to this, and I have it listed. Okay. So, we can see in using this module, the data validate IP module, we're checking for patterns that may or may not match an IP address, version 6 or version 4. So in this case, we're testing for a normal IP address that does follow the normal patterns, the required patterns for an IPv4 address, which this specific line right here would output would output matches IPv4 that would return true. Although prior to version 0.29 for this module, even this address 010.0.0.1, that would return true. Currently, it returns false, although this is due to a couple of interesting points. So if we look further into it, we can see some documentation. Finding specifically where it points to it. Okay, so we can tell that improper input validation of octal strings and Perl's data validate IP module allows remote unauthenticated users to perform intermediate blah blah blah. So essentially what this whole description mentions is that the extraneous zero in the IP address will be translated as an octet in octal notation to the operating system, and the rest will be translated as decimal. So the operating system will see this IP address as 8.0.0.1, although this module, data validate IP, will see it as 10.0.0.1. So the IP address that will actually be doing the work, whatever you might be doing, or whatever the attacker might be doing, will in reality be 8.0.0.1. Although this module, which will provide some layer of security, is only parsing this as the incorrect address. So this can essentially bypass any access control that you have in this network server. If you have a SQL server that is access controlling IP addresses and normally denies you based on this, if this server might be using this module to validate your IP address, you can, despite the fact that your IP address might be blocked or might not, or you might not be whitelisted in the first place, you'll still be able to get in and potentially gain a reverse shell of this server in question. All right, and further, the project summary. So, in conclusion, initially I set out to make this a much larger project. I think I had a little bit too high aspirations for it. I wanted to, I think, do the work of what is already a cybersecurity engineer. I wanted to find a completely original flaw in the Perl programming language, not in specific technologies, not in CVEs, or what have you. That turned out to be a little bit too much to handle, and resorted to doing a full statistical analysis and in-depth overview of a couple different CVEs, and I think that set the course really well for what I want this to be, a personal project that I'll be continuing further, to actually find a flaw within Perl, or perhaps any other programming language, as this kind of set the scene for not only Perl specifically, but generally just what CVEs encompass in the first place, how they're found, and what a cybersecurity engineer might do, or a researcher, a cybersecurity researcher might do to discover different vulnerabilities. So that is my presentation. I appreciate you listening, and have a good day.